Magnitude of friction. Leonardo da Vinci was one of the few scientists who were early studying the science behind the friction and all the physical force that are leading to the phenomena of the friction on the moving objects. One of the interesting facts that Leonardo found is that when you have a box and the box is on a rough surface and you're pushing the box with a certain magnitude of force, it doesn't matter which face you put the box on, the magnitude of friction generated against the motion of the box will be always the same. Through the studies of Leonardo da Vinci and the scientists following him on the same topic, they found out that there is a relation between the static friction force and the normal force, and this relation is proportional. And after more investigation, they found out that for the static friction, as long as the static friction is proportional in relation to the normal force, then the static friction can be represented in terms of the normal force. And with a severe and more investigation, they found out there should be a coefficient to compensate for the difference in values. That coefficient, we call it here the coefficient of static friction. So if you want to find the static friction force, the maximum static friction force in this case would equal mu, that's what we call mu, the coefficient of static friction, multiplied by the normal force. Since the magnitude of the force of static friction can be anywhere between 0 to the maximum value just before the motion occurs, then the general equation for the magnitude of force of static friction must have an equality sign. In this case, the F static friction, or the force of static friction, should less or equal the coefficient of static friction multiplied by the normal force. As we mentioned, can be represented as F friction static equals mu static multiplied by the normal force. Now for the dynamic friction, same concept applies. The force of dynamic or kinetic friction is proportional to the normal force. The kinetic friction force equals the mu k as notation for kinetic or for dynamic multiplied by the normal force. So you have F static friction equals mu static multiplied by normal force, and F kinetic or dynamic equals the mu kinetic or mu dynamic multiplied by the normal force. With that, we can find out the magnitude or the value of the kinetic friction force and the value of the static friction force. Now let's discuss a little bit about the friction characteristics. Firstly, the equations for static friction and kinetic friction are not fundamental laws, but they are approximation of experimental results. So scientists or hobbyists went to the lab and tried to study how objects are moving, and they have their own sensors and apparatus that can tell them what is the force applied. They add a mass to the object and they try to drag it with a certain force. They try to change the speed and change the acceleration values and come up with a table, as we mentioned in a topic previously. That table can be turned into proportions and relations. Those relations can be turned into equations. So as we can see here, the equations F friction static max equals the mu static by the normal force, and for the kinetic equals the mu k, or the constant of kinetic friction multiplied by normal force. By the way, if we need to know how these equations came out or how did the scientist reach to those equations, please go ahead and comment and I will be able to provide you all the details or create a dedicated video on that. So those equations for static force and kinetic friction force cannot be written as a vector equations because the vectors of friction and normal force are perpendicular to each other, because we know normal force is perpendicular to the flat surface or to the level of the surface, and the friction force always exactly parallel opposite in direction for the applied force. Both the coefficient of static friction and coefficient of kinetic friction, mu s and mu k, are proportionally constants that have no units. For a given pair of surfaces, the coefficient of static friction is usually greater than coefficient of kinetic friction. Remember the graph we had in the last lecture, where we said kinetic friction show up when static friction is being overcome by the applied force. So you can't have kinetic friction higher than static friction. The coefficient of friction depend on the materials forming the contact surface. So those properties are object properties. So you care about the object being affected or influenced by the applied force, and the surface where you drag the object on. Both of these play a major role in finding or defining the coefficient of friction. And it defines as well how smooth or rough the surface is, on how smooth or rough the movement is, and how big is the value of friction. So whether the surface is wet or dry, that make a difference. The temperature of the two contact surfaces are making a difference as well. For your reference, we have here a table for approximate coefficients of friction for some materials. Something to keep in mind always when you've been asked, or most of the time when you've been asked about a certain value with the friction problem, you should be given the coefficient of friction. Unless he give you everything else, then you want to find the coefficient of friction. But in real life, you know that copper on copper, scientists did the hard work and they already came out with these numbers. They put copper object on a copper surface and dragged in a certain force. They define that the coefficient of static friction for him is 1.6, and for kinetic friction it is 1. Same thing for steel on a dry steel, steel on greased steel, dry oak on dry oak, rubber tire on dry asphalt, rubber tire on wet asphalt, rubber tire on dry concrete, rubber tire on wet concrete, rubber tire on ice, curling stone on ice, Teflon on Teflon, waxed hickory skis on dry snow, synovial fluid on joint, that's in your body, 0.01 for the static and 0.01 for the dynamic.